right? You could read a long scenario and then there could be a one-word answer to it, right? As opposed, and then there could be some that involves a lot of calculations. Yeah, it's getting hot in here. I don't know what's going on. Okay. So I hope to finish this whole section today, but I might not. Then it will just carry over. Just a warning, I have an assignment for chapter 3. It's going to take a lot longer than the other ones, just because there is a lot of little things. I tried to make it shorter, but I was like, every time I looked at a question, right, and I tried to take them out, but I'd be like, okay, this is a concept that's important. And I'd come to it, and it might be the same concept again. And I'm like, yeah, students need to practice this at least twice, right? And then sometimes a new concept, and then at the end, it ended up being pretty long. But you have a while to do it, right? So just do what you can as you can, right? As we go through this. So today we're going to talk about relative standing, right? So think about the first chapter, right? The first section was measures of center, right? That's saying I have this data, roughly where is it, right? Then variation, okay, you've told me where to find it, now how spread out is it there, right? Today we're talking about relative standing and box plots later. So relative standing says I have one piece of data. How can I describe where it is with respect to the rest of the data, right? So everything else is about the entire data, right? Ours is saying, how do I compare, right? So I might, again, I always do this. The height of everybody, of all men, right? Of all adult men. There is some, I could use the mean, right? The mean adult height in the United States is 5'9". Standard deviation is 2 inches. I've now described its center and its variation. But another question might be, how does Bobby here fit in to all the men in the United States, height-wise, right? So that is what relative standing means. So that is what we're going to talk about for the rest of today, and it looks like tomorrow. So the most important measure, right, of relative standing is a z-score. You will be using z-scores the rest of this semester. So make sure you know how to do them once I go over them, right? I had pretty much every student who failed last semester were students who still could not correctly use z-scores by the end of the class, which is just disastrous, right? So make sure that's not you. It's not, I'm not saying it's going to say it's easy, because it's whether something's easy or hard depends on the person. It is something that once you master becomes easy, right? And so just, you're not there, spend time talking to somebody, me, Marcus, to get there, right? So you're going to calculate these and you're going to interpret these. Same thing with percentiles. You're going to create a box plot, which comes from something called a 5-number summary. That involves the Q1 and Q3 that I pointed out when we used the calculator, right? And I said I'll explain what that means later. So this section tells you how a piece of data, right, is compared to other data, right? We'll also talk percentiles, quartiles, which is another way you can compare it, right? And you can represent all your quartiles, right, using something called a box plot, which is kind of what it sounds like. It's a little diagram that has several boxes in it. Z-score. This is the formula for z-score. Memorize it. If you can't, memorize it. Tattoo it on the inside of your eyeball, right? You're going to need this. Don't actually do that, because then you wouldn't actually be able to see it, and that would be very painful, right? So we kind of used this when I was talking about the 2 standard deviations, right? So a z-score so earlier, I'm just going to go back to something, right? I'm just leaving this for a second. Don't freak out. These in B right here. Remember when I showed you this, right? And I said you might not follow it yet. We were calculating these z-scores so these were z-scores, right? So for example, we found out that someone with this body temperature has a body temperature 3 standard deviations above the mean. So a z-score is simply how many standard deviations you are, or a piece of data is, above the mean, right? Somebody that is large, something that is bigger than the mean, right? So the mean male height is 5'9". I'm 6 feet tall, right? That means my z-score is positive, right? My father-in-law, he's about, I think, 5'5". His z-score is negative because he is shorter than the mean, right? Someone who has a z-score of 2.31 means that they are, whatever we're measuring, 2.31 standard deviations above the mean, right? Let's just think about what this formula is saying, right? This is the difference between a piece of data and the mean, right? So if the mean score on the test was 65, yours was 70, you scored 5 points above the mean, right? But without knowing anything about that test, you don't know, is that a lot above or is that a little above, right? Perhaps almost everybody scored the exact same amount, in which case that 5 points is significant. Perhaps people scored all over the place, which it's not. So you want the standard deviation, right? Think about it. Tells you how much variation there is, right? It is a standard amount of variation. So how many standards fit in there is your z-score, right? And before I said, if something is 2 standard deviations above the mean, it's considered significantly high. If it's 2 standard deviations below the mean or more, significantly low. Standard deviations different from the mean is literally z-score. So everything I said about significantly high, significantly low, you can translate that into z-scores. We will show you how to calculate them, right? But this formula, pretty straightforward. Notice it's just data piece. Depends whether you're comparing it to a sample or population, but it's just measurement minus the mean divided by the standard deviation. You know, I've been teaching for a while. I still am somewhat idealistic, but I can get jaded, right? If I see you when you graduate, right, there's a good chance you're going to forget most of what I teach you, right? And that's just kind of how it goes. If you remember z-scores and what the hell they mean, I will be stoked, right? Like I will do laps around that gym because that's the most important thing that you're going to learn, I think, in this class. Okay, so here's a diagram, right? So as we said, what percentage of people were within 2 standard deviations of the mean? That was the mythical, important 95%, right? Does that sound familiar? Right? So if we look at people's weights, right, and your z-score is 0, that means you are average Joe. You weigh exactly what the average is. You are a textbook specimen. of whatever the hell is being measured. if your z-score is 2 or more, right, and we're talking about weight, you are exceptionally heavy, right? Only 2.5% of data is in there, right? That might sound mean, but maybe you're exceptionally heavy because you're exceptionally tall, right? Or exceptionally buff, you're ripped, or whatever the hell term you want to use for that. Molt, shredded. Oh, I'm tired, so I'm just saying synonyms now. If you are weight has a z-score that is negative 2.5, negative 4, you are significantly underweight. Maybe not in a medical sense, like that you're unhealthy, you're just much less heavy than the other people around you are. You are in the, so you walk down the street, damn, that person is significantly less heavy than average. Okay, that's what we're thinking, right? Notice that the z-scores identify significant values or not, right? They factor in what that population is like, right? So imagine an alien, for some reason, is asking about us. It says, alien who doesn't know anything about people, right? If you told an alien, right, you know, my statistics professor is 6 feet tall. 1, they wouldn't know what the hell a foot is. 2, even if they did, they wouldn't know if that is interesting or not, right? They don't know if that means like I'm the shortest person ever lived. People find me adorable, right? Or I'm the tallest person that ever lived, or if I'm very average. But a z-score, if you gave me my z-score, all right, his z-score is 1. They would say, okay, that person is taller than most people on Earth, but not exceptional, right? The z-score factors in what the mean is and how spread out that data is, right? So it's kind of cool in that it tells you how exceptional a piece of data is without knowing anything about the context of the data. See how that's a powerful concept, right? So let's just try to calculate some z-scores so we can figure that out, right? So, I mean, this is something I know something about. I've been told, right? I'm not a biologist, right? And I don't plan to have, well, I won't be having any children. My wife is not planning to have any children with me, right? So this is something I probably won't go through, right? I've been told that a pregnancy is 9 months typically for people. I really don't know if that's always the case or how much that varies. I know that if it's right, so here's what we're now being told this, right? So for each of these, you just need to calculate, right? So in this case, so here's the formula you use. You just have to look at the numbers here. So X is equal to the measurement for the particular individual or whatever it is. So look at this first part. What is X equal to? 322, 268, or 15? X is the measurement associated with an individual. Yes, so a woman, right, 322. She is a particular specimen, right? That sounds weird, but, right, we want to know what is the deal with her pregnancy length, right? Is it exceptional? Is it normal? Whatever, right? So then you need to use the formula, right? So the rest of it tells you this, and we should be good at doing this. It says length of pregnancies have a mean of 268 days. That mean, is that a sample mean or a population mean? Which means you use what symbol? Sigma is for the standard deviation. This is mu, which looks like the letter U. It's a U. It kind of looks like an M, but it's a U. Okay, it's the one, let's see. I know my handwriting's bad. Let me show you which one that. This is mu. This is mu. That's pronounced mu. I'm with. I get it, and it sounds like it. Yeah, I know. My handwriting's not good. You'll get used to it, right? I'm sorry about that, Mars. Okay, that means mu. It's the population. It is. If you have, I mean, we got a lot of folks here who speak Spanish. I imagine we don't have anyone here who speaks Greek. No. If you did, you would be using this letter to spell, right? And if you had know someone who's in a fraternity, you might know these letters, but you'd probably know the capital versions of them. Okay, so that is 268 days. And the standard deviation here is a population standard deviation. That looks like an O with a line through it, Regina. I think this looks like a cannon. That's how I first remembered it. Sigma. It is the lowercase sigma. It's weird. So this is also sigma, but that is uppercase sigma. That's what we use for the sum. Okay, all right. If you want, one's the sum, one's the standard deviation. It's sum. Yeah. Okay. Yeah. So this is the Greek letter S, but it looks, this lowercase version looks like the English O, and the uppercase version looks like the letter E. Right. If you want to take it up with Greece. It wasn't my idea. Okay. So then we just use the formula, right? So the z-score, that's this one. We all know what z looks like, so no worries there. It's x, right? So just think about this, right? This is saying how different they are, right? And then this is then you are saying that differences is how many standard differences, right? Because that mu, it doesn't tell you, right? That difference doesn't take into account how significant that difference is. And we'll just kind of look at it here, right? So let's calculate this. I'm going to use the units too. Kind of ran out of space there. So notice this is 322 days minus, I wouldn't expect you to write this out, the units each time, but you're going to see something. Divided by 15 days. Right. So I wrote it. I'm sure you have this 3.6. Okay. I want to show the intermediate part just so we can kind of get something out of this. So that's 54 days divided by 15 days. Which equals 3.6. Right. So notice days minus days is a number of days, right? If you've ever done, like in a chemistry class in high school, right, unit cancel it, right, like unit analysis, notice that when you're dividing days by days, the days cancel out. So this 3.6 has no units, right? It is a unitless thing because it is a ratio, right? Which is good if you think about it. So, right, if for some reason we decided to measure pregnancy lengths in hours, we would get the same z-score because everything would be adjusted appropriately, right? You would multiply each of these numbers, the 15, the 268, the 322, all by 24. Those would all cancel out, right? So the z-score is unitless because it does not depend on what units you need to measure, right? See, this is really useful. This is exceptionally high, right? Because remember, exceptionally high is 2 and above. So I don't know what happened. This baby did not want to come out. Maybe it got the news in there and it's like shit outside is bad, right? Inflation is bad. Everyone's yelling at each other on TV. Traffic is bad. I just don't want to be born, right? It's much easier in here. You can't really blame the baby, right? So that 3.6 knows how useful that is. If you told, right, aliens, right, or just clueless men who don't know anything about pregnancy, right here, okay, you tell them this woman's pregnancy length at a z-score of 3.6, they can be like, damn, that is a really long pregnancy without knowing anything, right? You need to know this information about pregnancies to calculate the z-score. But the z-score tells you how exceptional that pregnancy length is without you knowing anything about pregnancy. This is the power of z-scores. Right? Are we kind of getting why z-scores are right? Because it tells you, right, whether something is exceptionally long, high, or low without knowing anything about it. Let's do the same calculation here. Here, same thing. X in this case is, for this one, yep. I don't know why it won't let me write. Mu is 3152. All right, I'm sorry, that's a U. It's not an M. Mars is mad at me, but it's all good. Oh, this is my 6th hour of teaching today, so there we go. All right. Yep. So do the same calculation, right? Just using this formula. You will get a z-score of 1.22. So from this z-score, don't think about the context of the problem. Is this baby heavier or lighter than your mean baby? Heavier. Heavier, right? I'm not saying whether it's significantly heavier, right? That was my second question. So we're getting into it. You have to read my mind, right? So it's heavier because that is a positive number, right? If it were a negative number, it would be lighter, right? So make sure to be careful, right? Sometime when you're doing the one, we'll do ones where it gives a negative z-score, right? Your instinct is if you subtract two numbers, I always want the smallest number second. Make sure that that is correct, right? In this case, it is, right? Now, is this baby considered significantly heavier than your average baby? No. So this baby is heavier than average, but I don't know if you've heard this expression, nothing to write home about, right? The delivering doctor is not texting his wife and saying, damn, you should have seen this baby I delivered today, right? Now, on this one, he is. He's like, damn, I don't know what the hell is wrong with this woman. She's been pregnant forever, okay? This is something that happens one out of like, we said 3 standard deviations was 0.3%, right? This is even more than that. So this is something that happens like 1 out of 10,000 times, right? Like that is, right? If any woman is pregnant 322 days, she has a story to tell. And we know that because that z-score was 3.6. Questions on this, right? So the z-score tells us relative standing. Is something exceptional? Is it above the mean? Is it below the mean in a single number?